Lesson 3.6 is titled Equations and Problem Solving. This is for algebra. Okay, first, defining one variable in terms of another. So the length of a rectangle is 6 inches more than its width. The perimeter of the rectangle is 24 inches. What is the length of the rectangle? So if I have a rectangle and I know that this is width and this is length, okay, the length of a rectangle is 6 inches more than its width. So here's my width, I'll name that W, and then the length is 6 inches more. So I want to only have one letter or one variable because then I can solve the equation. If I made this W or X or Z or Y, I wouldn't be able to solve it. But since they're both in the same variable, then I can solve it. So then I would look here and I'd say, okay, that's W and that's W plus 6. So then they want the perimeter, keyword, perimeter. So I would add W plus 6 plus W plus W plus 6 equals 24. Count my W's, 1, 2, 3, 4. So I have 4W plus 6 and 6 is 12 equals 24. I minus 12 from both sides. So 4W equals 12, and then I divide by 4. So W equals 3. Now, if they ask me for the length of the rectangle, well, I know my width is 3, but my length would be 3 plus 6, which is 9. So I'm not quite done when I get W equals 3. I have to go back and plug it into the equation to see that my length is 9. All right, consecutive integers. We did a couple problems of these last year, so hopefully you remember this. Consecutive integers differ by 1. The integers 50 and 51 are consecutive integers. So if you remember this type of problem, the sum, keyword, of 3 consecutive integers is 147. Find the integers. So we're going to use this defining one variable in terms of another. We're going to use that same strategy. So 3 consecutive integers. So my first integer is going to be x. My second integer is x plus 1, because I would add 1. And my third integer is x plus 2. So do an example. Let's pick 10. If 10's my first integer, 10 plus 1 is 11, and 10 plus 2 is 12. Are those consecutive? 10, 11, and 12? Yes. So that's how that works. So now, the sum of 3 consecutive integers equals 147. I have to put them all as x so that I know I can solve the equation. So now I get 3x plus 3 equals 147. I draw my line. I minus 3. And I get 3x equals 144. And then I divide by 3. I don't know what that is. 3 divided by 144. Well, 3 goes into 14 4 times, which is 12. And then I have 24. 3 goes into 24 8 times. So my first integer, so if I put x equals 48, that's my first integer. So if I scroll back up, that's this number right here. Well, 48 plus 1 is 49, and 48 plus 2 is 50. So these are my 3 consecutive integers, 48, 49, and 50. All right, another thing that you're going to learn is uniform motion. An object that moves at a constant rate is said to be in uniform motion. So like a train, a car, a plane, those type of things that you're constantly moving at the same rate. The formula D equals RT gives the relationship between distance, rate, and time. We use this quite a bit. Uniform motion problems may involve objects going the same direction, opposite directions, or round trips. So I'm sure you've all heard of these type of problems. A train leaves a train station at 1 p.m. It travels at an average rate of 72 miles an hour. A high-speed train leaves the same station an hour later, and it travels at an average rate of 90 miles per hour. The second train follows the same route as the first train on a track parallel to the first. In how many hours will the second train catch up with the first train? So here's how they show you how to do this, okay? First you have t equals the time. And t minus 1 is the time the second train travels. So this is the first train, is just t. And t minus 1 is the second train because it leaves an hour later. So if this train, it took 5 hours, it would only take the high-speed train 4 hours because it's 1 hour later. Okay? Now, what they figured out is, well, the first train travels at 72 miles per hour and then times its time. If it takes 5 hours, that's how far it's gone. This one travels at 90 miles per hour and then t minus 1 is its time. So here's a couple different ways you can do this. You can set the two equal to each other because I want to know when they will equal. Okay, method 1, you could solve by using a table. So I have a table for train 1 and a table for train 2. And then I notice after 5 hours that they're the exact same answer. Or I can set the two equations equal to each other, solve, and I see that it's 5 is my answer. The second train will catch up with the first train. The first train takes 5 hours, second train takes 4 hours. Okay, so there's two different ways to do this. Now, Noya drives into the city to buy a software program at a computer store. Because of traffic conditions, she travels only 15 miles an hour. On her drive home, though, she averages 35 miles per hour. If the total time travel is 2 hours, how long does it take her to drive to the computer store? So, t is the time of her drive to the computer store. So let t equal the time of her drive to the computer store. 2 minus t is the time of Noya's drive home. Okay, if the total travel time is 2 hours, I would have 2 hours minus t, which is how much it took her to get to the computer store, and then that difference would be the drive home. So she drove 15 miles per hour on the way there, times her time, and then on her return she went 35, and then it was 2 minus t. It's not t minus 2 because it's not her time minus 2. 2 is her total trip. 2 was the total trip, and then I'm going to minus the ride there to figure out what her ride back is. So they set both equations equal to each other, and they got t equals 1.4. So on the way to the computer, it was 0.6 of an hour on the way home, and then on the way to it was 1.4. So it was quite a bit different because of the traffic. Okay, so try this one. On his way to work from home, your uncle averaged 20 miles per hour. On his drive home, he averaged 40 miles per hour. If the total travel time was 1.5 hours, how long did it take him to drive to work? So try this problem, and then we'll correct. Okay, so first you have your uncle averaged 20 miles per hour from work to home. So work to home was 20 miles per hour. Okay, I'm setting up a table. And then on his drive home, he averaged 40 miles per hour. If the total travel time was 1.5 hours, how long did it take him to drive to work? So, first you're going to have 20 times t, and then this will be 1.5 hours minus my travel time from work, to work from home, sorry. I wrote this wrong. To work from home. And then this is to home. So now I have my two equations. 20t equals 40 times 1.5 minus t. So then I'm going to simplify. So I have 20t equals 40 times 1.5. 40 times 1.5 is 60. I'm doing this. Minus 40t. So then I'm going to add 40t to both sides. So then I get 60t equals 60. And I divide by 60. So I know my time originally was 1 hour. And then, so that was from home to work in the morning. When he only drove 20 miles per hour, it was an hour long. It took him an hour. Then on the way home, when he drove 40, it only took him a half hour because the total travel time was 1.5 hours. All right, Jane and Peter leave their home traveling in opposite directions on a straight road. Peter drives 15 miles per hour faster than Jane. After 3 hours, they are 225 miles apart. Find Peter's rate and Jane's rate. So R equals Jane's rate. And they chose R because it says Jane and Peter leave their home in opposite directions on a straight road. Peter drives 15 miles per hour faster than Jane. So they related right here. They related Peter to Jane. So Jane has to be the R. And then Peter is R plus 15. That is a really key sentence right there. You have to make sure that you see that. So now I have their two rates, and they both went 3 hours. So I'm going to add them together. 3 hours times Jane's rate plus 3 hour times Peter's rate, and it equals a total of 225 miles. So they did that right here, and then they solved it, and then they figured out R was 30. So you're not done quite yet. So then you have to put that back into here. So I know Jane's rate is 30 miles per hour. So then you'd add that to Peter's, and then I would know Peter's would be 30 plus 15, which is 45 miles per hour. Okay, that is it for your notes.